Okay, good afternoon, everyone. We're back at the Circular Materials Conference. We should be in glorious Gothenburg at Chalmers, but as you well know, we are online this afternoon, but that means we don't have the chance to build some of those relationships, but we still have the amazing value of some extraordinary innovation, research, and business action that is taking place in our journey towards circularity. In this session this afternoon, we are looking at batteries for electric cars. Goodness me, the whole world of mobility is in significant transformation, and clearly batteries are the driving force for this transformation. And we've got 4 fascinating presentations on different aspects of what's happening within the whole battery value chain, and we're going to be exploring different aspects of this. 4 speakers, each giving about 15-minute presentation, and then we'll have a chance for some questions. If you want to be posing any questions, do so on the chat function on the platform, and we'll try and involve those in the conversation. So I'm going to go first of all straight to Hans-Erik Melin, who's Managing Director of Circular Energy Storage Research and Consulting. Great to have you with us, Hans. And I think you've been doing some work really looking at the whole lithium-ion battery recycling market. Goodness me, this picture I should think is evolving, changing and developing at high speed. So every time you look, I should think the figures and the trends are different. But Hans, great to have you with us, and really interested to hear some of your analysis of what's going on and what it means.
Oh, thank you very much. Yeah, very good segue. In fact, it is indeed an area which it's fast-paced. It's really hot right now, not least on the capital market. And it will also be a fast presentation, I hope, because I have 15 minutes and 29 slides, I think. So you should buckle up your cat here, Peter. So I'll share my screen. Hope that will work. There we go. Yes, all right. Yes, so I will be talking about the lithium-ion battery recycling market, but I will also try to really put that into context, into where the actual recycling part of that market will fit. So first, some family photos of what we are doing at Circular Energy Storage. So Circular Energy Storage is a London-based consultancy. I'm always nagging on recyclers that all of them claim that they are leading, but I think we are, to some extent, leading in the world, in fact, when it comes to data on the life cycle of lithium-ion battery market. We provide services to subscription and analysis. We also do a lot of consulting throughout the value chain, basically, the battery value chain. And they really, I wouldn't say all over the world, mostly in the US and in Europe, but increasingly also in Asia and in Australia. Often featured in publications where we are quoted in this regard. Also participates a lot in research, both in the US and here in the UK. And also in Norway, which I'm very happy for. So let's start with, another commercial. This is our service, our subscription service, and that is also from where the data is derived in this talk I'm going to do here. So let's start. So the lithium-ion battery market, just like Rasmus was indicating this morning, I mean, it's a market that is growing rapidly, but in fact, it has been growing rapidly for already in 20 years, but now it's actually not growing faster, it's just growing bigger in a sense. And it's becoming really, really big, and you can all see in the chart here what is really happening here, that we go from a market that was really dominated by portable batteries that already now has been overtaken by the electric vehicles, both the light electric vehicles and heavy electric vehicles. And to the right here, you see in tonnage how much battery that will be in use for the next decade. As you see, there will almost be 60 million tons of batteries that will be in use. And obviously, some of that might be available for recycling. It should, of course, be recycled. Okay, so what is actually reaching end of life? Well, it is a very different story. What we predict is that this year we will be close to about 300,000 tons of batteries that will reach end of life. And as you can see, in 2030, we are around not really 1.7 million tons. So very different, obviously, to what we have coming online. And if we look at what is actually reaching recycling, it is even more different. It is actually very much less than what a lot of other people predict that will be available. And that is basically what I'm going to talk to you about today. Why don't we see so much batteries reaching neither end of life or recycling? An important aspect of this image, in fact, is that many interpret this one saying that you could say it's about half of the batteries that will be recycled and half of the amount that reach end of life will be recycled. That is not necessarily true, because this is just showing, like, if you take, for instance, 2030, the amount of batteries that will reach end of life and the amount that will be recycled. That doesn't mean that the other half of the batteries won't be recycled further on, which is most the case. So you can't use this and say you have a recycling rate of 50%. Usually the rate is much higher than that. Here is a summary of it, and it really shows where the market is. It's obviously the markets today is really about putting batteries on the market, not really taking them back. And it will take a long time until we reach volumes that will be important, really, for the whole of the market. That doesn't mean that it's not important for individual companies or for individual smaller markets, but for the raw material as such, recycled materials will take a very long time to really make a dent in the market. If you look from a European perspective, well, then everything becomes essentially much less. To the left, you see the lithium-ion battery is available for recycling by region, and the Europe is in the lower part. And to the right, you see the distribution of what kind of batteries will be available for recycling in Europe. And as you can see, we still most of the volumes that reach recycling in Europe are from portable batteries. And in many cases, recyclers in Europe won't even see these batteries because they become available for recycling here, but they will often be recycled elsewhere, because we have a lot of traders from elsewhere in the world buying batteries in Europe, and a lot of them will not necessarily be recycled here. This will change, as you can see. We will see a lot of other different kind of applications, but it's also important to see that still in 2030 in Europe, we expect that the portable segment will still be the largest one. The reason for that is, of course, that we are now placing lithium-ion batteries. Much more lithium-ion batteries are placed in applications that last much longer. And of that reason, it will take longer for them, obviously, to reach end of life. And you also see that the biggest difference is really on the end of life vehicles, or the electric vehicles. So let's talk mostly about electric vehicles. That doesn't mean that other segments aren't important, but I mean, the growth is really driven by electric vehicles today, both light and heavy. These two charts, these shows the price development of used Nissan Leaf and Tesla Model S in the US. And as you can see, the Nissan Leaf hasn't really fared well. The average price for a Nissan Leaf of the model 2011 is about $5,000 now, almost close to $4,000. A Toyota Corolla 10 years would be like $10,000, but it's still $4,000. So it means that if you want a Nissan Leaf for 2011 in the US today, you have to pay $4,000. That's a 10-year-old car. And it also means that most probably you are not aiming to send that to the scrapyard right now. You can also to the right see here that the $25,000 Tesla that Elon Musk have been talking about is already existing. It is 8-year-old or actually 9-year-old Tesla Model S. What's interesting is also to see how the price is not that different, even if it has been driven very differently. So the mileage is not that important for the price. These are the kind of data we are using to predict when will the cars in fact reach end of life. Because what we have learned is that very few batteries will be replaced during the life of the vehicle. In fact, the older the car gets, the less we are driving. So it becomes the degradation of the battery gets less and less the older the car gets. I have myself a 6-year-old Vauxhall Ampera. I had 0% degradation in that battery, and I definitely don't hope to send that to the scrapyard in 2 years, which many recyclers are hoping I will. It will last for a very long time. So this is the first case. This is the reason why we don't see a lot of batteries reaching end of life. Another is that as they get older and the price goes down, they also get exported, both because they are old, but also because in some cases when they are lightly damaged, a lot of the cars will go to other markets. So here, what you are seeing here is from sales. From sales data in the US, UK, Germany, Norway, Russia, and Ukraine. And what you can see is the Nissan Leaf here, the early Nissan Leaf from 2011 and 2014, you find a lot of them in Russia and Ukraine. And you will also find a lot that in Sri Lanka and New Zealand and Jordan, for instance, also a big market for Nissan Leaf, although they've never been sold there because they've been shipped from Europe and from the US. In Ukraine, you don't have a lot of new cars, like 95% are used vehicles. Right now, the top selling vehicle is Chevy Bolt, which is obviously coming from the US. So they are getting shipped elsewhere. Also, if you look at the car, because if the battery is not replaced, then you might think that the car will reach end of life. And we always talk about that we have like the only 10-year-old cars in many of the countries. But if you look at a car like Toyota Prius, it actually lasts very long. And you don't see like a hockey stick here. It's not like it's increasing the older it gets. So we drive the cars for a very long time. And another thing is the export that plays in here, that a lot of cars that could have been reaching end of life here, that will go to other countries instead. So then what does actually end of life mean? Well, we have in warranty replacements, we have road accidents, and we have degraded batteries from end of life vehicles. As I said to the right, that rarely happens. We have seen a few in Norway, but otherwise we almost never see batteries reaching end of life that way. We will, but maybe not that many. In warranty replacements are often used for remanufacturing and sent out to become replacement. And then we have road accidents. And what's interesting is really how the batteries are reaching end of life is shifting. From that the in-warranty batteries have been a big part of it, but now it's really from accidents and real end of life. And that is very different because in the first case, the OEM has control of the vehicle, but in the second, they have not. So, it's a very different case. These are the ratios we are using in our predictions, average ratio. We use different ratios for every single model. But these are the average in the US and EU, and there you can see that we predict that more than 30% of the cars will be exported going to other markets, because other markets love electric vehicles. They are importing zero emissions, and we don't think that not until 13 years old, or the cars will be 13 years, and then we have about 25% been reaching end of life, and the rest will take much longer. Then you could expect, this is interesting, to the left here in this chart, you would see that we could expect a lot of cars reaching end of life in the end of this decade from the beginning of the last decade. And that is true if you look at per model, per year model. But if you look to the right, what you see here is that in volume, that is not really what is happening, because we place so many more electric vehicles on the market right now. So of that reason, there will be more new batteries that will become available. So when people talk about second life, that, oh, nobody wants to use those 20-year-old batteries, that might definitely be true. A longer life in the car will make them less attractive when they finally reach end of life. But most of the batteries are like 1 or 2 years. Today, you can buy a lot of used, like Porsche Taycan or Audi e-tron or Jaguar I-Pace, or even Tesla Model Y. So will there be reused or will there be recycled? Let's see, checking time. Yeah. Well, the reuse case is also like Rasmus was talking this morning. When you put this into well-structured, organized energy storage system, this is usually when you work proactively in partnership with the OEM. There are very few energy storage projects out there that has not have an active involvement of an OEM. There are a few, but there are few. Instead, the other batteries, they go into completely different kind of applications, such as conversion of vintage or classic ICE vehicles. And you might think this is like a niche business, 1 or 2 YouTube videos, but we follow 100 companies that do this around the world. Not everybody are using second life batteries, but at least half of them are doing that. Behind the meet the energy storage systems, we have both from like startups to the left here, from electrifying in Australia. Startups are, in particular, they are using Nissan Leaf batteries because they have been available in large supply. And to the right here, you see a do-it-yourself system in Jamaica. You see them in so many around the world, very popular as well. And also because cars are exported around the world, you will see a lot of upgrades and range extension of electric vehicles around the world. To the left, you see Nissan Leaf that's been upgraded from 24 to 30 and even to 40 kilowatt hour. And down you see Volkswagen e-Golf batteries used in a Nissan Leaf to do some range extension. And this becomes more and more popular, and it also keeps the batteries, of course, from being recycled, and also moves the batteries out of the original markets, which usually are China, Europe, and the US. Here's the average prices of used batteries. It's a huge mix, really, and it's all from batteries with a price tag on a shelf that might never be sold to almost a liquid market of modules from Nissan Leaf and Tesla. So I won't go through this, but this is just to show you this. The market of recycling is, recycling is just the last resort of a huge market, a complex market which is maturing, where you have a lot of retailers and vendors that have a lot of interest in these batteries, and there is a lot of value. And that value is usually always much higher than what it is for the recyclers. But there are other batteries that will go directly to recycling, from test vehicles, from off-spec production scrap, non-sold batteries. And many of these volumes are much more important. So if you look at the actual volume in Europe, you can see that the end-of-life batteries has been dominating, but now as we increase battery production in Europe, it will become much more important. And also as we finally really put our efforts into developing electric cars here and not only buying them from the US or Japan, we see a lot more test batteries, of course, also becoming available. And they are relatively quite important for the recyclers, which means that we basically, although we don't have a lot of end-of-life batteries coming offline today, but still it's tricky right now with capacity in Europe. And it's important to look at it from the recycler's perspective, because for them, lithium-ion has not been that important. If you look at, this is from Sweden from 2018, and you see the gray area is a lithium-ion battery. It's becoming more and more important in what sense we are placing on the market. But to the right, you see what is actually collected, and it's not very exciting for the recycler. It hasn't been, but now it's become that. So it will dramatically change. We today we follow 30 companies that have their boots on the ground in Europe and that are doing investments in recycling capacity, and you will see a dramatic change over the next 5 years. And both in terms of pre-processing capacity and in material recovery of capacity. So as I see it, it will be tough in many. It will be a bumpy road, sometimes with too much capacity, sometimes with too much supply, just like what we have in the raw material market. So here you see basically the capacity versus available volumes. So the key message: don't worry about mountains of waste or tsunamis of batteries coming towards you, and we will take care of that. It's definitely a very interesting business, but it requires clever skills or a clever setup for recycling, and that they are well positioned to make a business out of this. That's my, hopefully not more than 15 minutes. Thank you.
Thank you very much. Fascinating insight into the world, and obviously really interesting because you know, with the battery technology, particularly in vehicles, knowing what the predictions are for life and all the rest of it, we're now seeing some of the real figures coming through. And obviously it's going to be very interesting over the coming years to see as battery technology develops and evolves, presumably, you know, whether actually we are producing some pretty smart bits of technology which actually maybe have a longer life than predictions.
Yeah, absolutely. I mean, that's what we have seen so far. I mean, we actually already have it. We have seen it since, I mean, 10 years back. I mean, already by then the batteries are better than we thought.
Yeah, so maybe I shall hang on to my Nissan Leaf for more than the 3 years I thought, because when I started out, I thought I'd have my Nissan Leaf. I'll give it back after 3 years because the battery technology will have changed. But we shall see. Anyway, thank you very much. If anyone, people following this, if you've got a specific question on that presentation, then do tap it into the chat box, and we will include that in our conversations. But for now, thank you very much. And we're going to develop the theme further. And delighted to welcome Pavel Calderon, who's involved in an amazing startup called Nortical. And Nortical is developing software tool for understanding the degradation of battery performance and battery value degradation. So Pavel, you're one of the lucky ones who's in Chalmers in Gothenburg, and very interesting to hear some of your research, your analysis, and maybe what it's telling us about the circularity journey moving forwards. So great to have you with us, and over to you.
Thank you, Peter. Thank you so much for the introduction. And thanks everyone for listening in. I want to take you a brief presentation about what we have been doing at Nortical in a research project that we got going on at the moment. But I will start off with just a brief presentation of our company, Nortical. So the reason that we exist is that we believe that we can make sure that batteries are used more efficiently when they are in an application, and that we want to make sure that all the batteries actually come to recycling. A lot of what was spoken to about here before. So our company is just a quite young company. We were 10 people based here in Gothenburg, and our approach to this is that we gather. We are a pure software company, as you said. What we actually do is that we gather data about how batteries are being used out there in their applications. It's everything from electric scooters to cars and energy storages or screwdrivers, basically anything that uses lithium-ion batteries. We ship that data to our cloud and to where we analyze it. We use mathematical methods to analyze and try to predict the behavior of the batteries, and we deliver knowledge and insights about the batteries to our customers. And these things can be like how to use the batteries more efficient, when to charge them, when not to charge them, which batteries to use when, and how to dimension battery systems and things like this. But today I wanted to talk to you about a project that we have running at the moment, a project financed by Vinnova called Additive Transparency to Circular Flow of Batteries by Blockchain Technology. And the aim here is to try to understand a bit better what are the limitations in the battery to create a circular battery value chain of batteries, and how can this be improved to make this flow a bit more efficient. And there are quite a lot of members in the project, representing heavy duty vehicles, last mile applications, insurance companies, investment companies, and yeah, we try to keep everyone involved, everyone that has something to do with using batteries or in some way are affected by batteries. So what the goal is here is to try to understand better what impacts a circular value chain would have, and not only talk to these classical actors like the first life application, maybe a car manufacturer and then an energy company for a second life, but we also talk to insurance companies that make sure that they want to understand, for example, when an energy storage is installed in a building, how do they work with insurance? How much risk is there? Things like this. We talk to investors, for example, if a city wants to buy a fleet of electric vehicles, how do the investors react to that, and how do they make sure that their investment goes around? And these kind of entities. Also, very interesting, we're talking to fire departments and early responders about accidents and things what can happen with batteries. What information do they need so that so they can feel secure when they respond to different situations. And also another dimension that we are looking into is exactly how good is actually the circularity around batteries. How much are the batteries used, and when they are used, how are they used, and with what type of energy are they charged, and what does that mean from an impact point of view. So the things that we've found different type of barriers, like I think was mentioned here before, is that, for example, OEMs, they always work, they have, at least until now, they've always been working with the first application, and then they have to make strategic collaborations with second life users. There has to be a complete new organizational challenge, and there is also the technical, just how to rebuild batteries, and how much test you need to do to make sure that you know what the status of the battery is. Is it really worth shipping the battery maybe to Amsterdam, repurpose it there, and then ship it back to Belgium for use in an energy storage? So these kind of things, and actually understanding when is it not worth it doing this? When is it maybe better out of a financial point of view, but also environmental point of view, to just recycle the batteries and make sure that the materials go back into the next battery life. What we've done so far, then, this is a very messy picture. I don't want to go into details, but we've mapped out a bit how the information flow goes from the cradle to the grave, and how different actors share information at the moment, and also what we see is lacking. For example, there are a lot of other institutes that would benefit from data, like Chalmers here to develop new battery chemistries, or different other institutes like banks and so on that never get access to the data. And the data that is actually there is very protected. Of course, OEMs, they want to be restricted on how much data they can share. And the data flow is very linear and not distributed at all. So the findings that so far the project has about a year more to go. But what we see now is that there needs to be a more transparent way of sharing information. Of course, there has to be a way of protecting the information, so that sensitive information doesn't being shared to everyone. But the transparency in the information will be allowing for more efficient usage of the batteries while they are using, but also an easier way to go from a first to second life, maybe even a third life application, if it's already been planned in the first life application. The possible solution that we are working around is orchestrating a data sharing network, and this is where we are looking into how to be able to build the infrastructure of data sharing, but also protect the key IP that is there. Because we see that there is truly a way to make battery usage more efficient by understanding exactly how batteries are used and which entity uses batteries in different ways. So the close business potential is that by using so much, the battery is more efficient, and less batteries will be needed out there. And we see all these numbers that so many batteries are going to be produced in the future. If we can just, I think it's great, but if we do so many batteries, it's not really going to be a sustainable thing to do in the future. And I think we need to increase the trust and the transparency of how batteries are being used again. So the next steps that we are going to be building is that we are establishing a protocol or a passport of information of how batteries are being used, what kind of data does all these different actors need, what can they share, on trying to understand how much value does it actually bring to all these kind of partners that are in the project. We have started, and it's already ongoing, this third-party data acquisition platform that we are building to manage the data transportation. And we're actually working quite a lot with the EU legislation to try to develop new strategies and new legislations for handling of battery information in the future, so we can make sure that the batteries are used in as sustainable way as possible. And I think, that's about what I wanted to show to you guys of our work. Thank you very much.
Pavel, thank you very much. Very interesting research, and again, another pieces of the jigsaw emerging in our understanding of what is going on in the whole world of batteries. I'm going to drive us forward to hear our third presentation. Just to say, as we go through, If you do have a question or a comment to feed into our discussion at the end, then just add it on the chat section on the Circular Materials Conference platform, and that will come through. Not much so far, so maybe you are being fully briefed on everything you possibly ever wanted to know about lithium-ion batteries. If you don't know everything, we're going to add another piece to the jigsaw now, and delighted we're joined this afternoon by Lisbeth Dahllöf, who's a senior project leader and researcher at the IVL, Swedish Environmental Institute. Lisbeth, great to have you with us. And you've been doing a study on what happens to lithium-ion batteries, so probably building on some of the work that Hans shared information on. But very interested to hear your research project, some of the findings, and maybe what it's telling us in terms of this whole tranche of the circularity world. So over to you, Lisbeth.
Yes, thank you very much, and thank you for letting me talk this interesting conference. Yes, indeed, I'm going to talk about the fate of lithium-ion batteries, and specifically in the Nordic countries. And we were very much inspired by your work, Hans-Erik. And I will talk, but I hope you will get some new knowledge here too, and I hope it's not, and it doesn't seem to contradict, so that is interesting too. So yeah, we are the Swedish leading organization for applied environmental and sustainability research, and I want to add that we are environmental consultants for the automotive industry in general, so that's good to know, maybe. So because our study was in the late 2019, so there is already a report since a while. If you, it can be good to go to the report if you are interested in details. And the news, if I have some news after this time, because now we have 2021. So the background then was that there's a huge increase in cars and electric cars and trucks and heavy duty and e-scooters. And you can see to the right that there's a super high demand increase for the certain metals. You don't have to see all the names there, but it's lithium, cobalt, graphite, and the rare earth elements in that chart. So we need really recycling. But the question was when and how many and how much of the metals are recycled. And at that time it was the ongoing revision of the battery directive, which is now a proposal, the battery regulation, it's called now, that the Commission have proposed to the Parliament now. And this was an assignment from the Nordic environmental protection agencies in the work with this revision of the battery directive. So the research questions were how many of the used lithium-ion batteries for vehicles are currently sent for recycling in the Nordic countries, and how much weight and amounts of the lithium batteries for the vehicles are put on the market in the Nordic countries, and how many are available for recycling or second life in the year 2025 and 2030. And what are the future and current techniques for reuse, second life and recycling, and the advantages and disadvantages, and what is the material recovery efficiency. So we looked into what is collected then in batteries in 2018, and it was not so easy to find because the reporting is very scarce because there's a poor legal demand for reporting in the battery directive, the current one. But we found some data and we did some calculations from that. And we saw at the cars with about 1,700 around roughly, mainly from accidents and other warranty issues. We did not look into export, which is of course very important. That's what Hans-Erik told us. And buses, we project about 100 and 150 pieces from hybrid buses, and e-bikes a lot, around 30,000 to 43,000. we assumed 4 years use, and there was not e-scooters included. But the highest weight is from car and bus batteries, as you have heard. And the highest collection rates is from the heavy duty, because there they have the business contracts and producers' responsibility. And the second highest are for cars, because also there you have producers' responsibility, although the car owners usually own the battery, so they can do what they want with the battery. Or what they want, but they don't have to send it back. And actually, some of them are actually selling used batteries on the internet, on the auctions there. And the third highest, which is from e-bikes, that it's easy to send for collection, but it may be stored in homes for a long time, so it has a question mark when it's recycled. And there's always a small risk of fire. The difference between the chemistries, how high the risk is. So how much are then available then in year 25 or 2030? So we modeled, and we modeled for the high volume, I mean for cars and commercial vehicles and buses, because there you have the volumes, I mean the weight. So we saw that they last for, in generally, about 14 years. And we did the assumption that 20% goes to second life, and then we have an yearly increase of 2%. And it's 6 years in second life, and you need 1.1 battery to start with, because you have some damages on some batteries, and so you need more than one for one vehicle. And bus battery will last for 6 years, and you need 2 batteries for the lifetime of 12 years. And we said that 50% goes to second life with 2% increase every year. So it was assumptions. We did a scenario. So the base scenario, then we saw it just actually, to the left you have what is put on market, that we can see very easily in statistics. So that is safe data. And then we had these scenarios, and then it's around in the 2025, 2030, then it starts to be placed, can be recycled, then it's ready for recycling or second life. And the drop you see to the right is not a drop, actually, it's just we didn't have data more for more years. But the dark blue to the right is second life increasing then. And then we have, of course, different scenarios. If we have very high second life to the right, it takes a very long time before it goes to recycling. It starts in 2035 or something. And if you have high repair also, it also is, of course, takes longer time. That's logical, of course, it's scenarios. And then the question, what is other techniques? Currently you have pyrometallurgy or hydrometallurgy. And when you have pyro, you have a subsequent hydrometallurgy. And before you have pre-treatment usually. And then you recover the metal. And as Hans-Erik said, that it will be done, recycling. But when and where, the question mark is, because in Europe it costs money to send for recycling. And also it can be exported legally or so. And the efficiency can be improved, we think. And it's hard to get actual data from the actual recyclers we found. And lithium is currently not recycled in Europe, at least, from the lithium. It's downcycled at most. But that can be changed, of course, in future. And in theory, you can have very high, and in lab, you have very high recycling efficiency, a recovery rate. So that we know from the scientific articles, at least. And more resource-efficient processes are needed to make it economic and more efficient for circular economy. So there are a lot of research regarding automation and mechanical recycling. or better pre-treatment or other techniques. So there's a big development there. So the effect of the increase of batteries in cars and recycling it will start around 2030, and the collection will be done, but when and where is not, couldn't see. According to statistics, it was difficult. And there's also risk for fire, small risk. So it's not so nice to just store batteries in the long run because of this risk. And the repair and second life are evolving. So then it will take even longer to send for recycling. And it's not optimal recycling process. And the battery directive, we thought, should push for better metal recycling and also rules for repair to avoid risk of fires. And then news then. Well, you have the proposal for new battery regulation that the EU Commission have sent to the Parliament for decision. So it's not decided yet. Then now the batteries for electric vehicles will be reported separately when sent for recycling. That was not the case before. Now, a new reporting system for automotive batteries, also very good. And now if this will be decided, the proposal, there will be demands for recycling efficiency and degree of recycled metals that are put into the battery production. And lithium recycling will be a demand, although currently it's not so much economy, it's so cheap with lithium, so that will be a demand. And battery passport will be introduced then with the demand for life cycle assessment and traceability for the whole supply chain. And second life and refurbishing is even more attractive now. And there will be a lot of battery factories in Europe in the near future. I just found a map for all the different battery factories. And then you will have, they will need the raw materials, so then recycling of batteries will be more logical in Europe. So it's a lot of even more recycling research. And what I, as a consultant in the automotive industry, have seen, much more activities regarding circular design, LCA, and putting demands on suppliers more heavily also to work in a circular way. So, so actually also IVL, we work more now. We are involved in hydrometallurgic recycling in new chemistry there with organic acids. We do another round about batteries in the Nordic, changing for circularity. It's an assignment from the Nordic Council of Ministers we are very happy for. We do stock and flow models regarding the batteries. So we get more information and include these export aspects also. And the aim is to give information regarding the best practice in refurbishing and recycling, and from the design, and actually to give recommendations for the design for the cars and the electronics also. So it's easy to recycle the batteries, so that the Nordic countries will be the best countries in Europe in this aspect. And actually we have another project called Future Adaptive Design for Electric Vehicles. It's a project that RISE, and the Swedish large institute in Sweden, is coordinating, and there we, together with Volvo Trucks and Polestar, will really go into what will be the efficient business models and designs for prolong the use of the electric vehicles, which is very interesting. So I think it's very much activities so that we will improve circular economy the all circularity of the batteries. There's a bright future, I think, and very important. So the report, you find the link and my contact here. So thank you for listening.
Lisbeth,
Yes.
thank you very much indeed. More important and interesting information. And I'm sort of feeling quite heartened by this session. It feels as though there is some, although we're going to have a huge increase in the number of batteries, embedding circularity within the systems sounds as though it's something that is eminently possible. But we can maybe discuss that a little bit when we come to the end. If people have, again, we've got one or two questions coming in, but specific questions for Lisbeth or for our other speakers, then just add them into the little chat section on the platform you're viewing from. So we come to our last presentation, and delighted to welcome Martina Petranikova, who's Assistant Professor Nuclear Chemistry and Industrial Materials Recycling Department in the Chalmers University of Technology. Lovely to have you with us, Martina, and you're looking at more aspects of sources of battery production through to battery changes in battery chemistry and what all this means in terms of material supply and also recycling needs. So quite a comprehensive set of work you're involved with. But as I say, great to have you with us and look forward to hearing some of the emerging findings from your research work.
Thank you very much. And also thank you very much for letting me talk at this nice conference. And I'm really happy that I'm the last in this session, because now like all the statistics was shared and explained, and also the need for the recycling. So I can really focus on the technical part and technical importance and what can be done. So before I start, I would like to introduce our group a little bit, because I am from the nuclear chemistry and industrial materials recycling. And our main area is in the recycling of course, the recovery of the metals, but also the plastics. And our competence is mostly the hydrometallurgy, but now we are also starting with the thermal treatment, also pyrometallurgy. And we don't only do the research in hydrometallurgy, but we also do the optimization of the technologies and also the upscaling. So we also have a pilot plant for the recycling. So if there is somebody there who wants to develop the process and then also upscale it, then we are here and we can help. And we have been involved in a lot of projects related to the recycling of the batteries, and especially lithium-ion batteries. We have had international projects and also a lot of national cooperation with Nortical, with Volvo cars, with Stena Recycling, and also Nordic. And lately we have projects which are going a little bit further. So we are focusing on the materials which are currently not recycled from the batteries, like for example, electrolyte and organic components. We also currently got a new project together with the Volvo cars and Northvolt, where we are going to make a new batteries just from the recycled materials. And also, as Lisbeth mentioned, we also have another project where we will contribute with an LCA a lot of LCA in the recycling using different reagents. And today we have heard a lot about the needs of the materials for the battery production, and it is especially important since we are going to have a lot of battery producers in Europe, and they will need a lot of raw materials. But unfortunately, we don't have so much of these raw materials in Europe, and we still depend on another country. So we heard today Emma talking about Congo for cobalt, but also the lithium and also graphite has to be exported from another countries. And it is not that easy, because even though there are some resources of the materials, we have to keep in mind that if we need to produce our batteries, then some other parts of the world will be affected with these activities. So for example, when it comes to graphite, if we want to produce 1 ton of the graphite using the batteries, we usually generate 1 more ton of the waste. And also it is very important to talk about the lithium, and finally lithium is a critical raw material for the European Union, which puts a lot of focus on it, because even though it is made in mostly Australia and South America, where they use evaporation to recycle or recover lithium from the brine, they unfortunately are also consuming the drinking water from the region. So they're affecting the people living in a proximity of those mines. So we have to keep in mind that if we want to be really sustainable, what we have to do and what we should do, we should maximize the recovery of the materials from the sources we have, and those will be in the future the spent batteries. And today we haven't heard that much how it is really done. So I will spend a few minutes just like simply explaining how the recycling is actually done for the lithium-ion batteries. So in majority cases, and in the very close past, the majority of the batteries were recycled using pyrometallurgy. And this is a very robust method where we usually don't need so much of the mechanical pretreatment of the batteries. But what is the problem with the pyrometallurgical processing is that what we can recover or what can be recovered is mostly iron, nickel, cobalt, and copper. But metals like lithium, manganese, aluminium, and also, of course, electrolyte, they are lost in the process. And still, even if we recover those four metals using pyrometallurgy, we still need to use hydrometallurgical processing to separate those metals from each other. And then another method or another approach which we can have is hydrometallurgical processing, which usually requires some mechanical pretreatment. But in this pretreatment, what we can do and what we can separate is still plastic, aluminum, and copper, increasing the material efficiency of the process. What is usually lost is electrolyte. In some processes, it can be recovered, but in a majority of cases, it is not. Then another pretreatment what is used before the hydrometallurgy is applied is a thermal pretreatment, and it's mostly to remove organic components from the waste. And again, what is removed is plastic and also electrolyte, and then hydrometallurgy is applied. In a hydrometallurgy, what we can recover is, again, are all the metals, sort of, but usually, as I said, electrolyte is mostly lost. And if we summarize the processing, how does it look like nowadays in a majority of the cases, then we can see that from all the components coming as a material into the processing, usually only those four metals can be really recovered. And on the picture, you can actually see how does the slag look like. So in a pyrometallurgical processing, lithium ends up in this form of the slag, and it's in majority cases, it is not really recovered. And because the hydrometallurgy is not so familiar for many people, I will just briefly explain what it is and which steps are involved. So as I said, we can have before the hydrometallurgical treatment, we can have some thermal pretreatment. And then in the leaching, we are getting all the important metals and all available metals into the aqueous media. And we can sort of like recover all of them. What is not sort of, what can be also recovered within this process is a graphite, because it stays as a solid residue, so we can recover it. It's not that much recycled nowadays, but hopefully there will be some research dealing with this recovery and utilization again. Then another step very often is a precipitation, when something which we call impurities like iron and aluminum are removed. Sometimes also copper can be removed using precipitation. And the next steps is a solvent extraction. And sometimes copper, depending on the technology, can be used also or can be recovered using solvent extraction. And then it goes like first manganese is usually recovered using solvent extraction, then cobalt, and then nickel. And I just want to point out here that the solvent extraction is not one step. And you can see on the flow sheet below that solvent extraction is based on several different steps, which we call extraction, scrubbing, and stripping. And also what we should keep in mind is that for one metal, sometimes we can need, for example, 2 steps of the extraction, 3 steps of the scrubbing, and then more steps or 1 step of the stripping. So it's many steps for one metal. And then in the end, lithium is usually recovered using precipitation. So all of that is involved in the hydrometallurgy. And then how can hydrometallurgy help to achieve the sustainability is that it allows us to recover metals which are present in a low concentration, which is, for example, lithium in this case. We can achieve very high purities. So that is also very important if we want to reuse the metals we recycled again in the batteries, where a high purity is required. Then we can also recover metals which was otherwise lost in the pyrometallurgy. So we saw again the lithium example before. We also can change the technology to adjust to a changing composition of the waste so it's more flexible. In many cases, we can recycle the by-streams. So even though we can see that, okay, maybe there is some generation of the secondary byproduct, in many cases, they can be reused again in the hydrometallurgical processing. What is also very important to remember is that sometimes hydrometallurgy is criticized for use a high amount of the reagents, but we also have to keep in mind that for some of them, they can be used for many, many years. So for example, organic solvents, which are used in the solvent extraction, they can be reused for years, for example. So even though some reagents are needed, still they can be used for many, many years. And again, there is a larger flexibility in the scaling up of the processes based on the technology and also amount of the waste we have. But how can we, even though if we are going to use the hydrometallurgy and this kind of the processing, how we can even boost it more? So what we can do first is actually to improve the material efficiency by developing the technologies which allow us to recover metals or materials which are not recovered nowadays. So this can be, for example, the example of the technology used at our department by Dr. Buczak-Ebin, who is developing a technology of recycling organic components and also electrolyte using supercritical CO2. So it's not only electrolyte which can be then recovered, but also some organic other components, and it will also improve the further hydrometallurgical processing, because if we remove the binder, PVDF, from the waste, then we can separate better aluminium and copper foil in the batteries. So, and then the hydrometallurgy will need much lower amount of the steps for the recycling. Also, what we can do, we can decrease the energy consumption for the steps like thermal pretreatment, where we can find the optimal conditions and we can find the optimal temperature and also the time. So we can decrease the time and we can decrease the temperature, but we can also analyze the byproduct and see what is better. It is better to use pyrolysis, or is it better to use incineration for this type of the waste? Then we can also see where, for example, the fluorine ends up in this processing, which is also very important for the recycling companies. But we can also see how we can use and maximize, I'm sorry, all the steps used for, so for example, I'm sorry. So for example, we can see that we can transfer the lithium in the water leachable components and then recover it even earlier in the processing, and then we will not lose it in other steps. So for example, with a proper thermal pretreatment, we can transfer it into the carbonates and then leach it out with the water, for example. We can also apply organic acids instead of mineral acids, which will have also very high material recovery, but also lower environmental impact. We also, for example, cooperate with Nordic, who is a producer of reagents, and we can also decrease the consumption of these reagents for the processing. So then in the end, we will decrease the cost of the recycling. We can also optimize, we can also optimize the processing steps, and we can decrease the amount of these steps, which will be maximize the recovery of the valuable components, but we can also decrease the cost of the recycling. We can use better or more selective molecules. So again, we will improve the cost and the efficiency of the recycling. And also what is also important nowadays, even though now we know how to recover and how to recycle NMC materials, and we are already in those steps that they are recycled, what is needed to be done, it's to define how the impurities coming from the recycling, which are not present in the primary resources, how they can affect the performance of the batteries. So in our research, we can see that, for example, small amount of copper and small amount of magnesium, which is still can be still present in the precursors, it can actually improve the battery performance. But we also have to define the negative effects of the other impurities. So what is important to remember is that we have to use novel and more efficient processes in the primary and also in the secondary production or in the recycling. What will be a challenge for the future for the hydrometallurgy is are the solid state electrolytes, because they will use a different type of the materials, even different type of the metals. So this can really affect the future hydrometallurgy. So it would be really nice to consider recycling of these before their application. And how does the future look like? So we have seen it from Hans-Erik speech and also Lisbeth's speech, but I would just to finish with this one, that recycler like Umicore, they say that recycling cannot provide enough supply and we will still need a primary production. And primary producer of nickel, Nickel in Harjavalta, they say that recycling is necessary to satisfy the demand of nickel for EVs. Thank you very much for your attention.
Martina, that's great. Thank you very much, and have a large gulp of water and go out of the room for 2 minutes to have a good cough. Really interesting. All four presentations have given us quite a comprehensive view of kind of what's going on and some of the future prospects. What I'd like to do in just the time we have available to us is to really open up the discussion a little bit more. Again, if there are those of you who are participating who would like to ask a question, just put it on the chat and I'll convert it across and put it to our panel. But it's great we have a bonus ball with us this afternoon. James Lundstrom is back with us from who's head of circular economy at Volvo Cars. So great to have you with us. I don't know whether you've been listening in to the various pieces of research that have been taking place.
Partially.
Okay.
Apologize, but had to jump in and out a bit.
No, quite. It's quite appreciate that. But it would be interesting, James. Just obviously, batteries are at the very, very heart of the technology that is now being implanted within all Volvo cars. You may, I'm sure you're not a battery expert, but just interested from the point of view of a major manufacturer, just some of the work that you're doing and how you're seeing the development of battery technology that also means that circularity is embedded from the design end, so that perhaps in the future we'll be having less challenges in reprocessing and recycling than we currently face. So if you want to just offer us a few insights from the world of Volvo, that'd be great.
I think our strategy doesn't differ that much from at least our European counterparts. Essentially, we work with what we call a 1-2-3 strategy. So the first step is, of course, to be able to service and refurbish a battery, and we're establishing our own what we call battery centers, which essentially are specialized workshops that are authorized to open a battery, change out components within the battery to maintain it at a level of quality and performance where it can continue to be used in a car. Second step is looking at what's generically called second life applications, which generally tends to be some sort of energy storage. We see a lot of interest from all areas, from intermediate energy storage for instance, a charging station at a parking lot, all the way up to major energy companies who want to do backup for our offset load peaks for everything from hydropower, wind power, and so on. And third step, of course, is recycling. And there is there is a rapid shift. There's a lack of capacity in recycling compared to the amount of electric cars coming out, meaning that there needs to be more companies coming into this business. There is a very rapid technical development in material separation in order to gain quality of the residual materials from recycling. And what we also see is that will then have a direct impact on the residual value of these materials. If you went 5 years back in time, scrapping an electric vehicle battery was a cost. We absolutely see that there will be a profit from a residual value in the battery that supersedes the actual cost for recycling. And the next step, and I'm not sure, yet again, apologize for having to step in and out here a bit, but is the purity and the quality of the materials to where you can get out of it. And some might have seen that there was a press release today where we will be involved in the Swedish government project in trying to clean the residual materials from battery recycling to a further extent, thereby raising the quality and minimizing the need to extract more raw materials.
Interesting. And I mean, do you see just very significant further advances in technology around batteries, or is it one of these things that we've kind of worked out how they work, what they do, and everything is sort of at the margins, or do you think we've only just begun?
I think we've begun, and of course there's a lot of focus on durability of batteries. There's a lot of focus on the use of scarce materials like nickel and cobalt, which have been mentioned, and finding different materials and substances to be used in the cell chemistry to have less hazardous impact, especially on the mining and the extraction process. We're also seeing, and I know there's different design concepts, and some of the things we're working on are, of course, not something we discuss in public, but how do you integrate a battery in a car so it doesn't become that you build a car and then you put a battery in the trunk and it's not optimized from packing or engineering or safety, into having a battery fully integrated. And I think we're just starting to see the first good examples, if I include ourselves and our competitors, coming out on the markets where the whole vehicle, from basically the first design of the architecture, was done so fully optimized for batteries and not being a compromise between where to put the battery and where to potentially put an engine.
Interesting. Does anyone just wonder, I mean, it's really interesting hearing, right from Volvo. Just wonder whether anyone, Hans-Erik or others, want to just offer an observation on that evolution and what that's further telling us about the whole circularity within this area. Hans-Erik?
I think it's quite natural that everything goes in steps here. I mean, first of all, the automotive industry really needs to learn to make electric vehicles, obviously, and that has to be top priority. And that is actually, I mean, that is why we are doing this. So obviously, it's great if they are circular and adapted for recycling or designed for recycling. But I think we sometimes we are just exaggerating the problems. I mean, there are some batteries that are really messy to get into, but I mean, if you see the creativity amongst those people or companies that actually see the potential and opportunity in those batteries, I mean, they find their way in or to make use of those batteries. I think the main issue here is ownership. Volvo can't do much about the batteries if they don't own the car, or at least control it in some way. I mean, it doesn't need to be ownership per se, but I mean, Volvo can also be the best buyer of their own batteries from the users. But as the value of the car, that is relying on a cascading of the ownership throughout for between 10 and 20 years. If it's less than that, I mean, we have a problem, and Volvo has a problem. And that means that it's hard to say where this car eventually will end up, in which market, who will actually have access to the battery. And I think that is very much overlooked. I think we might see much more circular models in the where we have fleets, where we have, like for buses, where we could estimate that the batteries will in fact be replaced during the vehicle's lifetime, which I don't think will happen in many of Volvo's cars, because they will last longer than the actual car. But I think, not least like Lincoln Company, Volvo as well. Many in the Geely group has had quite clever ownership models, subscription models, and all that. And I think that, together with like connectivity in the car, shared mobility, there we have something that might become very interesting.
Right, thank you. I just want Pavel and Lisbeth, I see you very small on my screen. If there's any observation you want to further add in on this stream of conversation.
Well, I also agree about ownership, and the selling function is very something for the future, especially for fleets, as you say. and that is in this father project we have the Polestar and Volvo Trucks, a big package of work and very, very active automotive participants, which is very nice.
Yeah, I also agree. The ownership is very, very interesting. And one member of our project is, for example, Västtrafik, who doesn't own. It's not even an owner. They just they order another company to make sure that there's electric buses on the streets. It's not a company like Nobina or things like this. That is actually the fleet owner. But Västtrafik has the responsibility and more the political pressure to implement electric vehicles in their fleet, which they don't own. And then they have a lot of questions about how to invest in electric vehicles, how to make sure that they have charging solutions for it, and how to plan their routes and everything that they do. It becomes a really complex question for them to go electric.
Yeah, and may I just add to you? That we have also a project regarding public procurement of electric buses that I help the PTAs, it's called, and the ones that orders buses for setting environmental demands on the electric buses. So it comes demands from the society, and well, it's increasing a lot. So there are a lot of different parameters that have to be adjusted for optimal business.
Yeah.
Interesting. Okay.
Whoop.
As Volvo, you're having to sort of push the supply chain, and a little bit like Lisbeth was talking, as a procurer, you can sort of specify things you want, and reluctantly suppliers are coming along. Or are you finding actually that your value chain, your supply chain are actually driving the ambition in here, or is it a lovely hybrid that everyone's kind of working together to see how fast and where we can get to? Where are the forces for shift in this whole area?
You broke up a little bit in the beginning there, but I think your question summarized to who's sort of driving the shift here in battery development. And I think I go for sort of the hybrid answer. Yet again, when you, I mean, we were talking disruption this morning, and you see many large companies at the early phase of disruption, they vertically integrate everything because the supply base doesn't fully know what the customer wants. I mean, batteries aren't new. They've been around in laptops and cell phones and then cars and so on afterwards. So in essence, I would say if we look at cell chemistry, if we look at cell packing and so on, very much the development is done amongst the supply base. But when you come to, as I said, more, how do you fully integrate a battery from day one into vehicle architecture design, then that comes a bit more driven from the OEM side now, whereas 5 to 10 years ago, it was more driven from the suppliers saying, we have these cells and they take, you can pack them in squares or in rectangles or so on. And now that is more driven from OEMs. So I think we're seeing more involvement from OEMs here than maybe in many other types of component developments, which is more similar to maybe powertrain development, which is also very often done in-house on the OEM level. But suppliers are very quickly coming to the market, and we see, especially in China, where the electrification is moving very quick, that there is, I mean, there is a demand that is higher than the supply right now, and there is a ripe opportunity for startup companies to come and offer novel solutions, novel cell chemistries, and we see a lot of that. And the difficulty, of course, is to evaluate which one of these will be the actual successful ones and which ones can we truly believe will work in 15 to 20 years from now. Right.
Okay, interesting. I've just got a couple of questions coming in, which I'll see. Just put a hand up if you'd like to respond. First of all, one from Cecilia Vendin saying, I was involved in the H2020 application for a traceability solution for metals in batteries using the blockchain solution Circular. Wouldn't something like Circular be relevant also in this case? Does someone want to
I can raise my hand. We're actually using circular. We're actually using blockchain technology to trace the metal or some of the critical metals in our batteries. And we're doing this both to drive sustainability, or mainly to drive sustainability requirements and to drive credibility, meaning that, I mean, the whole purpose of blockchain is you can know exactly which material from which source and which origin that goes into which battery. So you have a complete traceability along the whole supply chain, which means that you can audit the supply chain and you know that what you're looking at is actually what you get, not just that you get a written statement from a supplier that we promise to do everything you ask us. So it drives sustainability in what admittedly is a difficult area, both from an ethical and a sustainability perspective today. So yes is the answer to the question.
Right. Does anyone else want to just add a comment on it?
Can I just short to comment? I mean, there are several solutions there out there. So I mean, many are working in that area. Personally, I just must say that I think we are totally over-engineering this, and I think it's a little bit. I mean, it's a product of where we are right now. I mean, I never seen any blockchain solutions on gasoline or diesel, wherever that comes from. So I think it's a little bit also a product of the entire debate about electrification of the vehicles, and that it's becoming. I mean, we can. I'm not saying that I don't want very strict requirements of how materials are sourced or produced. That I think that is essentially very important. But I see this in the new battery regulation as well, which overall I think it's a good. It's a step forward for sure. But I think we are going down to details which we know very little about how they actually will look like in 10 years from now. And I think the traceability of batteries, which will be better traced than the vaccines in the European Union or whatever. I mean, I think it's a little bit too much sometimes. But I mean, positive, absolutely. And I mean, I love obviously the concept of data to know as much as possible. So I think in general it's very, very positive.
Right. We should wait till we get.
May I give a short reply?
Please, James.
And I think Hans-Erik has a very good point that we're sort of drowning the world in data today. And there was an article in Politico a couple of weeks, which is a political newspaper in the US and in Brussels. And they had looked at an LCA published by Volvo and an LCA published by Volkswagen, and both claimed to be fully transparent. And their conclusion was they couldn't compare the two. On the other hand, I mean, blockchain is not done for public perception. It's very much done for us. And if you take a metal like nickel and you look at the vast difference in a mining operation for nickel that is trying to do it both ethically and sustainable, and those who are doing it just to make a quick earning, it is horrible what the difference can be. And if we are not actively pursuing to change that, then yes, you do not know that whether the car you're buying is contributing to killing the barrier reef or actually trying to make a good difference for the world.
Interesting. Pavel,
hello.
was it Lisbeth? So
Yeah.
you're very small in the corner, so you just have to...
You go ahead.
Okay.
Go for it.
Well, just a comment. I agree with that it's not unfair comparison with the old technology with diesel and electric. But on the other hand, many companies claim they are going to be carbon neutral in certain time. And then you need to be credible. And then this blockchain is a good way if you trace the CO2 emissions. So that's a way for avoiding too many questions about if you are carbon neutral or not.
Pavel, did you want to come as well?
No, I think you guys have all a good inputs to the debate, but just my experience with the blockchain and our project is also blockchainified, if you can say that, and then the step after, what happens to the batteries when they are on the street and afterwards. I think blockchain is a good tool to keep traceability and share information, and just make sure that the information you share is accurate and not tampered with. But I also a bit on Hans Erik's team that maybe it's a bit over-engineered. We will see. We'll see in the future what happens.
You wait till we have the first person who gets a blood clot in a Volvo car. We will stop cars altogether. Sorry, that was a little facetious, but it's very. But I guess the counter to this is, this is such a major step forward in terms of mobility technology. We all have a finger in cars. We just have to accept that there is a huge spotlight and interest in this area. So. Maybe it ultimately will be seen to have been sort of overanalyzed.
Just
Lisbeth,
one good thing for the LCA society is that you finally, hopefully, will get good data. We always struggle for getting data that is good. And now we see that activities in the supply chain they need to do LCA studies, they're part of it.
Brilliant. We need to bring this session to a close. I mean, what's exciting, I think, is that there's some really thorough research going on in and around this area, and clearly batteries have been a major player and going to be even more significant as we move forward. I'm going to do my usual, just give you the opportunity, for those looking in on the world of batteries and circularity, you just had a one-liner, a one message coming either from this session or how you see the future, or a warning or an idea, what would that be? So just to give us something as we emerge from this in-depth look at the world of batteries. Martina, do you want to start as you've not been in for a little while? Yeah.
If it should be only one message, then I would say that please consider recyclability when you are developing the batteries.
Okay, get in at the design end. Okay, thank you very much. Hans Erik.
Yeah, and I'm a little bit like Jonathan Swift saying that those who can't remember the past are doomed to repeat it. I think that's an important issue, but in the same time, to try to understand this market based on what is happening exactly today will not take you to the future.
Right.
That will be my. I think it's very important to a little bit try to predict what is actually going to happen and how things might look different in only a few years' time.
So we need to be very flexible. Okay, now I'll go to Chalmers and Lisbeth and Pavel. Just a message.
Yeah, I think we should listen more to the youth, because they are the future consumers and what they want to consume, and they seem not to be so keen on owning everything. So sharing after COVID, when we can share and be in the same car again and the same bus and so forth, I think we should listen to the youth and start sharing and acknowledge quality more.
Right, interesting. It's maybe that it's not that they don't want to own, it's maybe that in this strange world they can't afford to own, who knows, but maybe there is a bigger shift. Pavel.
Yeah, I think we live in a time now that someone said that everything that can be electrified will be electrified very, very soon. And then I think also we need to think forward and just make sure that batteries are used as sustainable as possible to actually make electrification sustainable. Otherwise, it's not going to be a good thing, I think.
Okay, and maybe just a final word from you, James.
I think we're in a very interesting intersect here between, as we say, the changing consumer behaviors, sustainability, and electrification. And I think the perfect trifecta of that is that we actually use and have transparency around sustainability, and then use the business model to maybe, and I know this may sound weird coming from my side, but that there's a willingness to pay for true sustainability and not just electrification at any environmental cost. And we can use this jointly to then develop the requirements that make the truly sustainable products.
Brilliant. Thank you, James. Thank you all. Absolutely fascinating session, and I hope those of you looking in have found it interesting, you'll also know who the people are, so do make connection with them beyond the confines of this conference. For now, we draw this parallel session to a close. You've got 15 minutes to take a breath, have a sip of water, and then we're back again. We've got one parallel session on construction and building materials, and I'm introducing a conversation cauldron, which is just a lovely mixed bag of amazing research and activity taking place around all sorts of aspects of circular materials. So I look forward to seeing you one way or the other at 14:45. But for now, we close down from this session. Thank you all very much indeed. Thank you.